Okay, you're given this piecewise function where we have some constants represented by a and b. Supposed to find the values of a and b that make f of x continuous everywhere, or differentiable everywhere. And that's going to imply that it's also got to be continuous everywhere. Then we're supposed to find the second derivative also. So if we go to board 2, here's that function with a and b still intact, and here are the correct answers. The next boards will show how. The black graph is the first derivative, the second derivative. The green graph is the first derivative. Of course, the red graph is the graph of the piecewise function f of x. And here's where the problem is. If b is something other than 3, then the graph on the right doesn't connect here. And if a is something that other than 1/3, we have something like a sharp corner. So we need the first derivative on the left equal the first derivative on the right. So how do we do that? Well, one thing you have to realize is that this e to the 1 over x term, as x approaches 0 from the left, is approaching 0. Here's how you can kind of convince yourself of that fact. If we put negative 0.1 in for x, that looks like this. 1 over 1/10 is 10, so e to the minus 10 is 1 over e to the 10th. And so this denominator is getting bigger and bigger as x gets closer and closer to 0 from the left. Okay, so if f is going to be continuous at x equals 0, f of 0 will equal b, because I put 0 in for this x. And the limit from the right of 0, I'll still be putting 0 in here, so the limit is still b. But that means we need the limit on the left side to also equal b. And since the limit of this term is 0 as x approaches 0 from the left, this term will also be 0. That means we get a limit of 3. And that means b has to equal 3 in order for the function to be continuous. In order for f of x to be differentiable at x equals 0, then we need the derivative from the left to equal the derivative from the right. So the derivative on the right of 0 is 3a. And if we apply if we get the derivative of this, we have to write this as e x to the minus 1. And so the derivative of that is e x to the minus 1 times the chain rule will be negative 1 x to the minus 2, or negative 1 over x squared. And that's where this comes from. And then the derivative of the x is 1. I'm not going to bother talking about how the limit of this term as x approaches 0 is 0, but it is. And so as x approaches 0 from the left, the first derivative will equal 1. And 1 has to equal 3a, because we can't have tangent lines having different slopes from the left and right of 0. So that means 3a equals 1, a equals 1/3. And here is the first derivative again. Here's the second derivative. We have to apply the quotient rule to that first derivative. This is what you end up with. And the derivative of of f prime is 0 when x is greater than or equal to 0. And here's a table that kind of shows that, yeah, it looks like these derivatives are equal. So these are the actual derivatives using the Desmos derivative operator, and these are the defined derivatives right here. Okay, and they're giving equal values, so it looks like that is the second derivative there. There you go. Hope that helped. If you have any questions, post a comment.